Jokes.
I didn't have any fun facts. So
Robot
jokes.
jokes.
Okay, we are rolling.
All right. So today's first speaker is Jonathan Doherty. Jonathan is the business development manager for Heidenhain Corporation. You may have seen their booth out front. Heidenhain is a German-based manufacturing company at the forefront of semiconductor, electronics, metrology, automation, medical, energy, biotech, and a bunch of other global markets. The company has been supporting these industries for over 130 years, and they just finished working with the ABB Gopher robot. Jonathan failed to provide me with any fun facts about himself, so I Googled him. And I'm happy to share that he hasn't aged a day since he was hired in 2014, so he's probably a vampire. Let's give Jonathan a big hand.
Appreciate it, thanks. All right, thanks. Appreciate it. All right, so today I'm going to be talking about robotic encoders from our company Heidenhain. So I appreciate the intro. You can see some of the solutions every time I turn my head. Okay. That we have up here on the screen. And so I'm going to give a little bit of a background on what encoders are, and then also some of the new innovations that are helping to support the growth in the robotics industry and what they're looking to do going forward. So I do ask maybe no pictures, please. There's some confidential stuff in here, but if you do have any questions, please feel free to ask, and we can ask afterwards. So, key characteristics for robotics in general. When we look at the robotics market, there are some certain things that, in general, people are looking to improve upon as we go forward into the next age of robotics. And so, right off the bat, one of the big things is obviously performance, right? Everybody wants to be faster, wants to be more accurate, more repeatable. And what that comes with is, better integration of components and better sensing capability. I don't know if some of you may have heard the term like Industry 4.0 or Industrial Internet of Things. As we see more automation and more shift towards automated manufacturing, robotics have to be able to do tasks that were previously not capable of doing. And so that's where this higher performance drive primarily comes from. But with that, we go to our second topic there is robustness, right? You want these robots to work in multiple different environments. They have to be able to work around humans. They have to be able to work in manufacturing environments, different temperatures, going through a cycle in a manufacturing warehouse in the different times of the day, vibration, some sort of dust, contamination. They have to operate in all of these different environments. And so robustness of the robotics is definitely very key. And then helping to support all that are also the sensors. This is where our encoders also come in, and I'll get to that in a second. But you have other sensors, too, that are being integrated. Things to help with the dynamics, torque sensing, joint and axis tilting, temperature sensors to make sure that your components aren't overheating. All of those are going in and basically providing more and more information for the robot to be able to draw from. And then finally, the big thing is safety. So a big trend that we're seeing in the robotics industry is historically you would have these large industrial robots. You think of something in like a automotive manufacturing plant or a welding. You'd have these large robots operating in very restrictive spaces or in cages basically. So anytime anybody entered that space, the robot would have to shut down because you don't want to risk injuring your workers. You want to be able to make sure that there's no possibility of a potential failure. As we move forward, we want robots to actually work collaboratively with humans, right? You want to be able to have a human worker directing and working with a robot as it does the task that it's involved with. So this is where things like cobots or collaborative robots come into play. But as you work with humans, you also need better safety. You need better redundancy to make sure that the robot isn't going to suddenly move or have any sort of reaction that could potentially harm the individual that it's working with, right? So we're moving towards dropping those cages, but ensuring the safety of those workers with the robots as well. And so these main four things drive a lot of the industry forward, but also drives, for us as a component of robots, how we develop as well. So within a traditional robot arm, what our company focuses on is basically the component inside of the robot. So we do a lot with internal motor feedback. So the motor that's driving those joints and the overall movement, we're providing that feedback on the speed with our encoders. We're also doing internal joint positioning. So as you have the movement, you want to know exactly where you are down to arc second level, which is basically 360th of a degree, so really small increments within those rotary positions. And then also the communication between those, right? So you have all these different sensors, you have all these different inputs coming from different levels of the robot, and you need to standardize and have a solution that brings that information back so that you don't have hundreds of different wires being routed through your robot overall. And so our company, Heidenhain, focuses on trying to improve each of these elements and provide the best solutions for the next age of robotics going forward. So as we talk about the first step here, internal joint positioning feedback, we can talk about some solutions that already exist and some new ones that are coming around too as well. So for joint positioning feedback, a lot of the common solutions that we see out there are magnetic encoders. And so these are very cost effective. They usually use partial arc scanning that you can see here. And you can do absolute positioning, which means that you know exactly where it is on startup, but it usually takes something like a calibration run or something like that. So our company saw that, okay, there's some room for improvement here. There are things that I think are really good, but there are also things that I think we can improve upon. And so we developed our inductive encoders on the right-hand side. We also have some examples at our booth if you want some hands-on feel of these. And these are basically a 360-degree scanning solution. So as opposed to just having a partial arc, where if something like eccentricity or some sort of tilt happens, you could potentially lose signal. With ours, 360 degrees around, able to compensate for that tilt and actually have really wide mounting tolerances to help with that development, to help with that integration. They're also insensitive to things like magnetic fields, which would affect a magnetic encoder, and absolute at startup. So right away, if you power cycle your robot or if it turns off, right when you start up, you know exactly where you are because every single positioning on this encoder has a very unique code. So even if the robot moves or if something knocks into it, it still knows exactly the positioning that it's going to. So we've seen a really big trend towards the inclusion of these within more and more robot designs. We're seeing a lot of integration due to the ability to handle even things like contamination and the no calibration. And then we also see things related to functional safety. So we talked about that portion, right, with the safety control. With functional safety, you get basically a safety integrity level. You can go 1, 2, or 3. And what you need in order to reach those higher levels is to develop things like redundancy. So with our encoder, you actually can develop 2 independent positions that can compare to each other. And then that makes sure that if there's any slippage or anything that's going on, your encoder knows exactly where it's at and what's going on. And so you don't have any situation where it could potentially harm an individual. So with that solution, we were basically looking at, okay, what exists and how can we improve upon it? But our company likes to also try to do more innovative things to push the market forward as well. And so that's where we come up with a solution for a 2-in-1, taking the motor feedback and the joint positioning and putting it together. So we got a little video here. Let's see if it works. So this is what you would see as a typical joint within a robot. And what we've done is actually take the motor feedback on the backside of this encoder and then have the gearing on the back of the joint coming through and then having positioning on the other side of the output shaft. So what this provides is instead of having 2 independent encoders within a solution, you can combine it into one and reduce your overall costs, reduce your overall size, all while eliminating backlash error, zeroing error, all these things that contribute to inaccuracies within a robot development. So as we talked about, you're trying to improve the performance. These solutions provide that all while providing an advantage on cost and sizing as well. So as kind of a cut up, you can see here kind of the design from a basic sort of standpoint. You have the motor over there driving the overall joint, and then you have the gearbox on the back side that then drives the output shaft, which is connected to the back end of the encoder. So there's a ton of advantages that come from this, both from the cost and the sizing standpoint. But one thing that we've actually just started getting into is actually the ability to take both of those measurements and actually do torque measurement from it as well. So a lot of robots have functionality like safe torque off or safe torque functionality for safety as well. And a lot of the time you have to integrate a separate torque sensor into the system in order to do that. What we found with our testing data is that you can see here a torque sensor would be the blue, and then our solution is on the green. And you can see that it's very, very, very accurate to a standard torque sensor, to the point where we've actually had companies that now can eliminate another component with our solution by being able to use the 2-in-1 encoder solution in the comparison. And so this is, again, another advantage, another cost saver with using the solution to drive the industry forward. And then the last thing I'm going to talk about is interface. So this is the connective tissue that brings everything together. This is basically the language that all of these components use to talk to the main computer of the robot. And so for us, we have an interface called NDAT, which stands for encoder data. And we've had a lot of iterations of NDAT over the years, starting actually back in 1993, so basically as old as me. And then having generational iterations going beyond that as well. And so our latest version is actually NDAT 3. And the big advantage for NDAT 3 is actually providing more communication capability, more sensor integration, all while providing a reduction of overall wires and a reduction of overall cost with a single cable solution. So with the NDAT 3 features, we have universal across all of our encoder brands, various scanning, various sizes, measuring principles, and things like that. And then also integration of other sensors. You'll see out in the showroom out there, there's a lot of different companies doing things like force sensing, temperature sensing. We even have some like vibration sensing stuff. And all of that can actually be integrated within the NDAT stream, so that instead of having multiple wires coming back, it can be just over one cable communication. It's extremely fast. You can go up to 25 megabits per second, even going into very long cable lengths, and then also providing diagnostics so that you can understand, okay, what's actually going on in my system, how is it working, and what is the overall current health. And then the details about, the communication of how it works. You can actually program things down to the encoder so that you can have commissioning data. You can even read out automatic system installation information so that your end user can know exactly how the mounting should work and what sort of conditions it should be operating off of. So all of this stuff is basically, able to be written down to and then read out by the end user of the robot or the motor that it's going into. And then finally, we talked about with safety. We always want to have safety first, primarily in mind, and we try to make it as simple as possible to integrate high level of safety within our solution using the NDAT 3 interface. So, just as a conclusion, we talk about the 4 keys of robotics going forward with the performance, robustness, sensors, and safety. And our company focuses specifically on trying to provide products for each of those. So we want to have dual encoders to provide overall performance to robotics going forward. We have a robust scanning method that allows you to work in multiple different environments, multiple different temperatures. We have integration of more sensors so that you can see more into your robot and understand what it's doing. And then, of course, safety. We want to make sure that we have the top-level safety performance to make sure that everything's operating as it should. So yeah. That is the conclusion of my presentation. If you guys have any questions, please let me know. But thank you for your time. Appreciate it. Great. Anything from the group? Go ahead.
Yeah, you're providing components. Sorry. You're providing components within a larger robotic system. I'm wondering kind of how NDAT interfaces with other programming languages, or maybe is it doing all of the controls in that protocol, or just wondering how it integrates with other things?
So for us, we actually collaborate a lot with motion control companies and motor controller companies. So a lot of the big names you'll hear out there like Rockwell, B&R, Siemens, Colmorgan, and NDAT is typically integrated within their motion controller for that sensor level communication with the encoders. So we work really hard to make sure that all of those different solutions will have that, and so that you're able to integrate it into whatever sort of end project that you have as well. Absolutely.
Thank you. This might be a high-level question, but in robotics, things are becoming more advanced and more feasible. So kind of like the way it happened with the AI recently, that now everyone is building on top of ChatGPT. Where do you see that turning point in robotics where it will just become more commonly used than there is this revolution. Where do you put that in the future?
Interesting. That's a very good question. I would say that there is a difference between the common usage of industrial robots, the common usage of consumer robots. So I'd say industrial robots, they've been used for decades within the automotive industry, and you're seeing a more shift towards automation in a lot of industrial spaces. I think COVID actually drove a lot of that because obviously you can't have workers coming in. We need to make sure that people are staying safe during that time, and automation was partially a solution to help with that, right? You can automate a line and then have it still operating. So I'd say industrial robots, you're starting to see that happen now. More and more industries are saying, okay, is automation a solution? How can we integrate it, right? Consumer robots, I think, is another side of it, right? The integration of robots within, society as a whole, as a delivery driver, as cleaning the windows on the outside, elder care is something I heard today. I think that's going to take more time, and again, as you work with humans, you got to make sure that you have that level of safety and make sure you have that level of comfortability that people are okay interacting with that robot. But you're starting to see the beginnings of that. I think that's a longer timeline, but you're starting to see companies starting to come out with those ideas, and I think that's just going to be a comfortability of the people with those interactions as well. Yeah. Any other questions? All right.
Thank you, Jonathan.
Thank you so much. I appreciate you guys' time.
Our next talk is going to be at 1:30, and you won't want to miss it. We have a very, very cool teenager giving the next talk. Thanks, Jonathan.
Absolutely.
Thanks. I'm going to go hunt down the next speaker.
Yeah, no problem. This is interesting. As soon as I turn my head, it goes off, right? So it might be better, whoever you put it on, put it up here. Okay, because I felt like I was
still got 3 minutes.
It says there's no audio coming in from the live stream.
Try it now.
Oh no, that's just what my dad is saying. Like on the live stream.
Tell your dad he's awesome and the audio's coming out.
Okay.
Tell your dad I say
Give him a
hi.
sound check. You could give a shout out to your dad. You can put it to your shirt. Yeah, that's perfect. Let's get a little sound check.
Like this? Hello?
Yeah, but you
Hello?
don't need to hold
Oh,
this.
hello?
Hello?
Hello.
Sounds
Oh,
great.
okay.
And let's try that one.
Hello? Can Fatima's dad hear me?
I don't know. Let me ask. Okay, he says now audio's coming.
Tell him I'm coming over for dinner.
Okay, I just did.
We've got 2 minutes.
You count us down. Tell us when we have 30 seconds.
Okay.
Yay!
Fantastic.
I don't own anything with a second hand these days, so I'm just gonna make it up.
Make it up. There's always time.gov.
Is there?
Best website. Time.gov.
I refuse.
I use it for Tucker and I have time.gov for classes.
What's trying to go?
Yeah, so it tells you what time it is. Oh wow.
I don't know what's up with society today.
Missed.
I'm gonna opt out.
Also, it would be really great if you ever have the opportunity and notice these chairs are empty,
I can sit there.
guide people to
I will guide people.
If anyone feels like shifting this way, our video looks a lot better with people sitting here.
I think the Harvard classes online do that. They put little Muppets in the front seats.
Yeah, they huddle.
Oh.
No.
When do we start?
We are.
Oh, we're starting like right on the dot. We're being really punctual with it.
I wish I knew some jokes. Haven't gotten.
Wait, do you do
Got a
two
joke?
truths and a lie with the other one?
Yeah. I feel like the Venn diagram between people who do jokes and people who are in this building right now, not a lot of overlap.
Yeah.
30 seconds and all.
They're all in the room. All the jokers are here. You just served barbecue like 3 minutes ago.
Huh?
You just served barbecue.
Yeah.
Comfy in the couch.
Are we recording? Let's do it.
Are we on? Okay.
Thank you for joining us for another Tech Talk today, and I hope you're having fun at the robotics party. All right, our next speaker is Fatima Hussein. Fatima is a 2-time winner of the Gold Presidential Service Award and a 2-time TEDx speaker. She's the inventor of Perky 3D Prints and Unicorn Lock, a CAD and 3D printing-based business, and 2-Minute Maths, a YouTube platform dedicated to encouraging enjoyable math. She's also run summer iOS development boot camps, and she must be doing that in all the spare time she has after all this other stuff. After winning first place in the country's biggest bioengineering competition, this 17-year-old learned that age doesn't determine success. Perseverance does. So let's welcome Fatima Hussein.
All right. Thank you so much, Ren, for that amazing introduction. Hello, everybody. My name is Fatima, and in today's talk, I'm going to be talking about how I jump-started my 3D printing business, and hopefully from this presentation, you're able to learn a few tips for running your own business. So a little bit about me is I'm involved in a bunch of different STEM extracurriculars, but a lot of it surfaces around robotics and iOS development and 3D printing. So I've hosted 3D printing pop-ups previously in my local communities to showcase my 3D prints, like in my Unicorn Lock pop-up over there. And then I've also been presented with the Presidential Service Award, as Ren mentioned, where I was awarded by Joe Biden and recognized by him. And my most recent TED Talk was in November, where I was flown out to the UK to speak about a loop called Hell's Feedback Loop, which is a mentality-based presentation. And I've also been a part of a lot of bioengineering competitions, and I'm also a former member of my robotics team. And last year, we also placed on a global level where we were the top 2% of teams worldwide. And we were able to go to Texas, which was really fun. Like in that photo right there. So that was a really amazing opportunity. So some few tips of before starting your 3D printing business is, number one, to research your interests. Like, just go on, Google and search up any of your ambitions or any passions that you think that there is a market for, or a problem that you see in your daily life that you think could be solved by 3D printing, and just narrowing down the specific target from there. And number two would be to figure out the type of problem and issue that you're trying to solve and how it can be solved with 3D printing or 3D designing or CAD modeling, and then writing a basic step-by-step procedure to kind of understand how you're going to tackle that specific issue. And then number three would be to what sets your solution apart from perhaps the current solutions that are on the market, or if you are a unique solution, what would make the customer want to go to you instead of other potential markets. And I just want to talk about my 3D printing businesses. So the first 3D printing business that I founded was Unicorn Lock. And so basically, this was all self-taught using like Udemy and YouTube courses, because in my high school, we didn't really have any 3D printing courses. And I really wanted to learn how to 3D print in the comfort of my own home, and how to render a design that could be turned into a tangible model in just a few hours, because I found that to be really interesting. And then from there, I did a few CAD projects on my own and a few custom designs. Like, I made a soap dish for my bathroom, and I made like Tesla Cybertrucks, just few day-to-day life things that I could use in my home. And then I found a specific issue that I could solve with 3D printing, and that was the fact that I have a baby brother and he loves taking my stuff from my cabinets. So I was like, you know what, I'm gonna create my own type of safety child lock with 3D printing. And so I realized that there's a market for this. And especially as a youth, I thought that I could leverage my age, and I could probably reach out and network and connect with babysitting clubs or daycare centers to kind of get my Unicorn Lock out there. And I did so successfully. And then after that, I founded my most recent 3D printing business, which is Perky 3D Prints. And this was after Unicorn Lock, and I realized that there was always a market for like 3D printed figurines and toys, especially the customizable types. And I've always enjoyed 3D printing and designing, and I know that people love having, customizable objects and toys. And I thought that using my 3D printing designing skills, that would be a perfect way for me to utilize it for my business. And it also gave me an opportunity to work with like Shopify and Etsy and kind of market my products and reach out to other 3D printing businesses and create online ads. And then, so I want to talk quickly about like the process. This is a very like simplified, narrowed down version of the process that I use to create my 3D printing businesses. Number one would be like the designing component, obviously, like kind of planning out your models and iterations. So I'll give you an example. Like for my Unicorn Lock, I probably had like 30 iterations until I really found the one that I wanted to use and I wanted to sell. So it definitely takes a while to figure out, the best version of your product and then settling on that. And then number two would be prototyping. Of course, this comes with designing. Like, you can design and then print it, and if it doesn't work, you just redo that procedure over and over again and compare those different versions. So this is some screenshots I have from Unicorn Lock. As you can see, I have a bunch of different designs and renders. And that was like one of the very few successful prints. I definitely had a lot of failed prints with starting my Unicorn Lock journey, because it was my first time using a 3D printer, and it was my first time printing on a 3D printer. So it was definitely a really unique experience for me. And I definitely learned a lot through the process, as there was a huge learning curve. And then this is the journey of Perky 3D Prints. There's definitely much less fails in this business compared to the previous one, because I had a little bit of experience with working with Unicorn Lock. But as you can see, I still had some fails. Like I was printing like part of a FIFA trophy and it like messed up, so I had to like reprint it, and it was a 10-hour long print, so I wasted a lot of filament. But I definitely learned a lot from that experience. And then also rendering it on Fusion 360, which is what I did for some of my clients because they wanted customizable objects. And so I created in Fusion 360 and then I printed it and then I sold them on my shop. And so when it comes to starting your business, I think a really important question to ask yourself that I think I didn't ask myself for Unicorn Lock is to realize like the scalability of your business. Like how specifically is 3D printing and how specifically is your CAD business scalable? I find that it's pretty hard to actually scale your 3D printing businesses because there's so many factors that goes within the whole process that could just mess everything up. And so therefore the things to keep in mind of would be like maintenance, like, updates and costs. If your 3D printer breaks down and you only have one printer, what are you gonna do? Specifically like target audience. Do you have a large target audience? Is it just a few people in your area? Are you gonna be able to profit off of your business? And also advertising, how are you going to market your product out there? And in terms of expanding your business, I think this was really helpful for me specifically on leveraging my youth because I'm a high schooler. So it's definitely like really different, to see, youth individuals like tap into like these fields that you see usually like college graduates or engineers would usually tap into, which would be like 3D printing. So if you are a high schooler and know someone who is a high schooler who's interested in 3D printing, definitely get them to start because once you start, I think it's much easier to just continue going and just bouncing back through those failure. And then also starting locally, what I did is like I networked with my community. I got out to like my high school. You can post it on like local newspapers and local businesses. And then last but not least, I think this is the most important actually, is to like seek mentorship from people who have experience in these fields. I have one or two mentors who are really experienced in like 3D printing and designing and who have worked in like those big unicorn companies, and they were really, really helpful in my process. And I definitely would not have gotten as far without them. And then last thing I want to talk about is like the concept of failure. So I think especially like in school, right? Like it's very like obvious that once you fail, you don't have the opportunity to retry on your test or retry for a better grade. And I feel like it doesn't really teach you the purpose of life, which is that failure is not only a part of entrepreneurship, but it's also a part of life. And it's literally inevitable. So here are some of my fails from Unicorn Lock. Like it was honestly such a mess. Like I still remember like my whole printer, oh my God, my whole printer collapsed and it just got ruined because of this one print. And I had to rewire the entire thing and it ended up being a drastic fail. But I actually learned a lot from that experience. And I think going back, I'm really grateful that I had that sort of experience because it's taught me a lot of valuable lessons working with my printer moving forward. And so some questions that I kind of ask myself and I find to be really helpful is, what could have gone better and what did I learn from this? You don't just fail, you don't just be disappointed and just give up. When you go through these hardships and obstacles, it's always important to make sure that you're learning something from it and you're making sure that you're not repeating the same mistake again, because that could cost time and energy. Yeah, and then moving on and just starting over again, I think is really, really important as an entrepreneur if you want to be successful. And that's basically it. You can connect with me on my LinkedIn. I brag a lot on there, so you can definitely, see a lot of my projects and a lot of my works. And, feel free to shoot me any questions if you're interested in reaching out or, just want to talk. I'm totally happy to do so. Thank you.
Do you want to take any Q&A?
Sure.
What do you 3D print? What do you print?
So basically for my most recent business, Perky 3D Prints, I built 3D printed models and figurines. I printed skull masks, FIFA trophies, that I've created customizable nameplates. So just a bunch of different things that I feel people would enjoy having on their desk or having in their room.
Where did you sell them?
I sell them on my Etsy store.
Nice.
It's called Perky 3D Prints.
Very nice. Cool.
How do you know the price? How do you come up with the price? How do you know your pricing? What do you come up with your pricing?
Yeah, that's a good question. So I kind of figure out the actual cost of the material, the electricity costs, the filament costs, and how long it takes for my printer to run everything, and then take that into account, and then also take into account my packaging, how much I'm buying for each piece. the material and the cardboard box. And then after I take all of that into consideration, like I want to figure out like how much margins do I want. So I would say like, for example, like I sell like the FIFA trophies for like 20 bucks, like it's like a miniature version, but I probably like spent like $4 or $5 making it in total. So the great thing about 3D printing is that it's not actually costly to create the models. You just have to really fine tune your printer, and that's like the part that takes a lot of time and energy and effort.
Yeah, thank you for sharing all of your experience here. Still in high school, but what are you planning to do after?
I'm definitely planning to like continue running my own company and just kind of being my own boss. I'm not sure if it will still be these companies or if I find a new one that I have more passion or enjoy more, but definitely, you know, continue running my own companies and being an entrepreneur is kind of what I want to continue, like my long-term goal.
You said something about scale, so just wanted to ask how you handle large volumes of printing then and how you handle it now. Is there a difference in that?
Yeah, so when I first started, I like just had one printer, for example, and it would actually like frequently break down a lot because I was new to like 3D printing. And so the thing with 3D printing is like it's a huge learning curve, but once you get over that learning curve, it's like really smooth and really easy. So if you want to scale, right, so that would depend on like how large you want to scale. If it's just like too medium, you could have like 4 or 5 printers. Like one person that I know, they have a pretty big business, but they have like a 3D printing farm in their garage. So they have like 20 or 25 printers that they continually maintain, and they have somebody separately to just, they're just in charge of maintaining those 3D printers. So you could just like hire somebody where their sole job is just making sure the 3D printers are running right and smoothly.
All right, thank you, Fatima.
Thank you, thank you.
Our next talk is going to start on the half hour, and we'll have a speaker from Foxglove. They have a booth up and to the right from here if you want to check them out. I'm going to go hunt them down. Good job.
Thank you.
That was a good talk. Thank you so much. Here, hold on so we can move again. I always mind what I say.
Need a clicker.
30 seconds. Are you recording, Noel?
On air.
It got over the safety. Tech Talk is canceled.
Yeah,
Unicorn time.
This is the real interesting thing.
Little space. More space. Okay. I want to start now, but I don't want to have to compete.
Someone can pick the unicorn up and
You're going to sit back there. All right. So our next talk today is by Adrian McNeil. Adrian is the CEO of Foxglove. I hope you visited the booth out front. It's a Bay Area company specializing in visualization and debugging in robotics. And in lieu of a traditional bio, today Adrian has kindly provided us with 2 truths and a lie. Number 1, he's from New Zealand. Number 2, he has 2 small children. And number 3, he recently hiked to Everest Base Camp. So by a show of woos and yas, who thinks the lie is New Zealand?
can't make that
They're
up.
on to you.
What is the first line again?
There are-
That he's from New Zealand.
Are you from New Zealand?
This is 2 truths and a lie. Okay, who thinks the lie is that he has 2 small children? Who thinks the lie is that he recently hiked to Everest Base Camp? Who
No
is
one wants
afraid
to
of
commit.
public speaking?
Me. I was not afraid of it.
There we go. All right, Adrian.
All right, we'll tell you at the
enlighten us.
end. Yeah, you don't find out. Hey, I'm Adrian from Foxglove. As I was introduced, I won't tell you what the lie was. Who has heard of Foxglove? All right, great. Here you go. You get a candy. You get a candy. Very nice. So, Foxglove is data visualization and debugging for robotics. We have a booth. Come say hi. So, robots. We're all excited about robots. That's why we're here. There's a lot of, you hear a lot of talk today about self-driving cars and other sort of, very hype use cases, but by the end of this decade, robotics are going to be ubiquitous. There's all of these different types of robots that are being built now. That you see some of them here today. There's people deploying robots in factories. There's people deploying robots in farms. We've got drones. We've got cyborg delivery. All of these are kind of part of robotics, and they all require very similar types of sensor technology, very similar types of navigation, very similar types of AI and machine learning. Unfortunately, one of the things that's kind of holding back robotics development that we see is that the developer tools for building robots are just not there. So Foxglove is a company we've been around for a couple years. Before starting Foxglove, I worked at Cruise Automation, the self-driving company, for about 5 years, and spent a lot of the time building the in-house tooling that helped us log data on the vehicles, analyze data from the vehicles, get it off the vehicles to the cloud, simulate the vehicles in a fabricated environment, remote assistance for the vehicles. How do we connect to them when they get stuck and get them out of that situation? And even just fleet management. How do we assign tasks to the vehicles? How do they pick up a task? How do they kind of notify you when it's complete? All of this infrastructure needs to be built from scratch today. And when you go and talk to the big self-driving companies today, you go and talk to Waymo or Zoox or Cruise or Aurora, they're all building all of this stuff in-house. And that's fine, because they have 2,000 people and billions of dollars, they can go and build that in-house. But then when you are building a self-driving forklift or a self-driving lawnmower, you don't have thousands of people, you don't even have tens of people. You have 3 people and a lawnmower that you need to automate. So Foxglove is here to sort of help build some of this tooling that you can use to get your robots into production. And the tooling that exists today, or I guess prior to Foxglove, is sort of pretty outdated, right? So you've got people copying files onto thumb drives, you've got tools that are only working in Linux, and you've got some of the like ROS and Aviz tooling is been around for a long time. You know, it was great for its time when it was built in 2010 or 2012, but you know, it's another decade has passed since then, and it's time to evolve. So at Foxglove, we do a couple of things. We do visualization and debugging, and then we also have a data management backend. On the visualization side, this is an open source tool that we provide, so you can connect it to any type of robot. It can work with ROS data, we can work with protobuf data, JSON data, all sorts of different types of data. And specifically, I guess, you know, this tool helps you investigate multimodal data. So when you're doing traditional software engineering, a lot of the data that you get from software is either sort of time series data, it's just numeric kind of plots and things, or it's text log data. It's just, oh, I'm going to read through these logs and figure out what was going on. When we're debugging a robot, we can't just read through a bunch of text logs and figure out, like, why did this robot crash, or why did the robot fall over, or trip down the stairs or something. We can't just look at text logs. We have multimodal data. We have camera images, we have maps, we have plots, we have 3D sort of images and environments, point clouds. So we need a platform that can help kind of investigate and debug this multimodal data. What else? Yeah, teleop. We also do teleop. That's another kind of type of thing that you need to do with a tool like this. And yeah, we support tons of different data formats. So like I say, it's open source. We support ROS, ROS1, ROS2, protobuf, JSON. You can also use the visualization tooling for both a live connection to a robot. So you're just sitting there, you know, make it drive, see what it does. Or you can do it with recorded data. So we've got log files. I've recorded these log files. I need to, you know, go and investigate it later, figure out once I'm actually back at my computer what's going on. I don't know, is anyone who's familiar with ARVAs? Have people heard of ARVAs, used ARVAs? No? All right. No one gets a candy. All right, you get a candy. Hello, robot. There you go. Oh, no, you get a squashed candy. All right. One person said it. So in the ROS, who's heard of ROS? Let's start, easier. All right, one over here. See how good my throwing is. You already got one. All right. So ROS is a ROS is a robotics framework that you would use, software framework that you would use to help build robots. ROS comes with a tool called ARVAs, which is, like I said, it's been around for a long time. That helps you do this type of debugging. But yeah, Foxglove has sort of a few. It's a newer platform. It's built on top of a web stack. You can plug it in with cloud data, things like that. You can kind of just like seek and find easy, you know, parts of your data, and you know, so we have dark mode, which is very trendy these days. How much time we got? So the data platform piece, I also kind of mentioned, you know, I'm working on my robots locally. That's great. I'm just one or two people hacking on a project, and then my robotics startup starts doing really well, and we start building dozens of robots, and we hire like 50 engineers or 100 engineers. And then we build like hundreds of robots, and now we've got hundreds of robots and hundreds of engineers, and we need to give all of the engineers a way to get access to all the robot data. So this is what people typically build when they start building their robot. They get their robots out in the field, and then the robots are logging data, and then they start kind of uploading it places. And some of it goes to Dropbox, and some of it goes to Amazon S3. And it's in different formats, and you've got video data, and you've got ROS data, and you've got, you know, text logs. And then you have all of these different kind of stakeholders, different people in the company that want to access it, and they can't because it's a data swamp. It's just all kind of, it's just, you know, all messy in there. So yeah, this is another part of what Foxglove can help with. Aside from the visualization kind of front end, we also help companies grab all of their data off the robots, store and index it, make a nice kind of clean environment, and then provide an API for different teams to do what they need. What else have we got? Oh, live demo. Should we do a live demo? All right. So we will jump into. I'm just going to pull up Foxglove Studio. Make sure I don't trip over this thing. Okay. So yeah, like I say, we can do live data. We can also connect to files. I'm just going to open a file here because we don't have any live robots to demonstrate with, and also I don't have a very good internet connection. But yeah, this is kind of the Foxglove environment. So like I say, if you're building hobby robots, if you've got a FIRST robotics team, if you've got you know, any even in a company setting, you can kind of either download this app to your computer, or you can just go to the website. Doesn't even require an account. You can just kind of go in and start feeding data into it. Yeah, so we're in this environment. looks kind of bare bones to start with. We've got kind of a basic grid and a bunch of transforms. We'll hide those, but we can start kind of showing topics. So we can bring up the sort of base map that we've got here. We can add in things like lane markers and boundaries. We can add in things like a model of our little vehicle, and then we hit play and see them start driving. Yeah, see kind of what's going on in the scene. We can turn on LiDAR. We can turn on, what else? Markers. Oh, what else are we detecting in the scene? A bunch of vehicles and things. And then we can also start bringing in, like I said, we can create an image, throw it up there. There's a bunch of different cameras on this car, so I think we can change that to like the front camera. And then maybe we want to get sort of just inspect some of our raw data as well. So we'll bring this over here, leave the camera up there. Get some of this, and then maybe start plotting a few things. Rearrange this kind of layout however you want, and maybe we'll get another camera up there. So yeah, we can kind of camera front, left, yeah, and then hit play, debug it. And so the reason you would use a tool like this is, and again, this is a self-driving example, but it might apply to your self-driving lawnmower or your self-driving tractor or your kind of warehouse robot. But we're trying to debug something, right? We're like, why did we slam on the brakes here? Or why did our robot crash or flip over or trip down the stairs, whatever it's doing. To do that, you need to sort of investigate the data. You need to go in and say, oh, well, we slammed on the brakes because we thought this guy was about to pull out in front of us. Why did we think that? He had his indicator on. I don't know. You might want to like plot little, oh, this is the path that we were planning on taking, and then at this point it changed. Yeah, so you can do all of these kind of different visualizations, and it's really up to you what you put in the scene. We don't give you any, there's no preconceived thinking out of the box about what you're trying to visualize. You just decide, I want some lines here, and I want some sort of 3D model here. Yeah, so that's more or less it. We're Foxglove. We're sort of fully remote company, but good presence here in the Bay Area. I live in the Bay Area, and yeah, we've got a booth just kind of over that direction, so come by if you want to chat. And we're open to questions. I have one more, so you may. Oh, sorry, it's a crushed one.
Which one was true and false from the 3 statements?
Which one was, right, so the 3, what did we have? We had I'm from New Zealand, and we had 2 small children and hiked Everest Base Camp. Well, I don't know, what do you think? All right, I'll narrow it down. I'm from New Zealand. All right, I'm from New Zealand.
Maybe you only have 1 kid, so maybe that's the...
No, I have 2 kids, yeah. No, I did not hike Everest Base Camp. It sounds fun, though, one day.
The third one.
Yeah, the 3rd one was a lie.
How big is your team?
We're about 20 people. Yeah, we work with a lot of different, like I say, different kind of self-driving companies and different robotics companies, and yeah. Yeah. You can put any data you like in, but we have specific types of visualizations that work well with cameras and work well with point clouds, LiDARs, GPS. Like, there's a bunch of different types of data that we work really well with.
Microphone, please. I can't hear your question on the screen.
How can you apply your data to agriculture, for example?
Yeah. So like we work with a few companies in the agriculture space. Same kind of thing, right? So you've got there's different types of things being built in agriculture. Some things are just like self-driving tractors. Some things are like autonomous sprayers or things like this. Same type of thing though. At the end of the day, it comes down to, let's say we have an autonomous sprayer. It's got some cameras. There's some decisions. So you've got different state, like is the sprayer on or is the sprayer off? Maybe we're detecting, are we detecting weeds or are we detecting that this is like a carrot or something? So you want to be able to kind of render that data and see, oh, this is my camera feed, and then this is kind of the decisions that were being made. So same thing, where it's used as a debugging tool.
Can you speak a little bit about the cost of your technology?
Yeah, so the visualization is all open source and free. And then, so if you're just working with local files or local data, that's free. And then if you are working with cloud data, you want us to help organize data in the cloud, Depends on how big your team is.
Then you will sell that as a service.
Yeah, it's a SaaS tool. Yeah.
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 Okay.
Cool. One over here, I think.
You're gonna answer the question.
Yeah.
But like, wasn't really clear where the data is hosted. So can you clarify on that?
Yeah. So where the data is hosted depends on if you can go to a website. So you can visualize local files or just like a live robot connection, and it's your data. If you use our SaaS platform for sort of indexing and storing all of that, we can either host it for you. It just runs in Google Cloud, and it's all sort of like fully managed platform. Or we can actually deploy it into customer cloud environments. So we have customers in Amazon or Azure or Google, and we can sort of deploy that into customer environments. Yeah. Any other questions? I'm out of candy, sorry guys. That was all I brought.
Thanks, Adrian.
All right, thanks.
Our next talk is at 2:30. We're going to have a representative from Hackster.io.
Cool, that was fun.
Yeah, thank you.
Great.
Good talking.
Hello, Robot Block Party. My name is Alex Glow. I'm here from Hackster.io, and I'm here to talk to you today about graceful technology. Hackster is an online community of hardware developers sharing open source tutorials. We've also got a popular news site, interviews and unboxings with Arduino, Raspberry Pi, Adafruit, SparkFun, etc. excited to go live. We'll see how it goes.
Awesome.
Okay, cool.
We're only 30 seconds.
Sweet.
behind.
Where should I stand? Can I roam or should I have to be in a box?
Let me introduce you.
Between the table and the monitor, more
Cool.
or less. But I'll find you if you wander.
That's creepy and all.
Vaguely menacing.
All right. Thanks for coming, guys. Our next speaker is Alex Glow. She's from Hackster.io. They have a booth here today as well if you haven't stopped by. They've got the best stickers here today. Alex creates tech unboxing videos and does interviews on open source electronics on Hackster. Her favorite projects are a laser-etched song that orbited the Earth and her companion core PCB for building companion bots. She has a couple called Archimedes, Fenrir, and more I haven't seen yet. She's currently building a directory of resources for people who want to build sustainable electronics. And she does Space Song Sunday on YouTube, where she sings a new song about space every week.
Most weeks.
Most weeks.
Occasional.
She's got a video present.
Oh, hey! Fix It Clinic.
Fix It Clinic every third Friday. Here, 6 p.m. until late. Fix It Clinic. So Alex has got a video presentation for us, and she's going to be doing a Q&A.
Yeah! So I assumed it was a video presentation, but it sounds like most people are doing it live, so I'm going to do it live because it's more fun that way.
Let's do it live.
But we're going to have some chaos. Not on purpose, that's just how it's going to be, but that's fine. So if you're curious, you can find all the tabs, the links that I'm going to be showing at this QR code. I'll show it again at the end, don't worry about it. I'll also put it on my Twitter, I'll show my social handles at the end, and you'll be able to find all this stuff because I think it's fascinating and deserves more attention. So, what is Hackster.io? We are an open source community, a community of open source hardware developers. So people sharing tutorials about all kinds of stuff. We've got cool news articles, we've got contests where you can win cool stuff, hardware to build with, as well as grand prizes. I do our videos, and we can look at some of those later maybe, but yeah, so I'm a person who didn't really come out of the tech community to start with. I did do first robotics in high school, which I love. Shout out to Team 677. And then I went to, then I went to college for human languages, and then I helped start this hackerspace in Ann Arbor. Shout out to AHA. As well as helped, was a director at Noisebridge for a year, for whatever that's worth. It's an awesome space, but the point of being a director was to not seize power. And I've got a bunch of different projects, including companion bots, which I love to build, custom PCBs, wearable tech, sustainability projects, and what I call mind-altering gadgets, which are ways to use technology to help your brain work better without implanting stuff. That's very important. And I gave a talk a few years ago about graceful technology, and people wanted to hear more about it. So tech with grace, what do we mean by that? Balanced and fair technology, minimal and purposeful, smoothly integrated and accessible, positive and life-improving, and elegant, which might mean that the tech is invisible, but we'll get into that. So it will all become clear. First up, balanced and fair. This is basically sort of the opposite of what AI is right now. There is a really wonderful statement by Mathieu, I've forgotten his last name, but I heard this a few years ago and I had to go search it up. Machine learning is like money laundering for bias. It's a clean mathematical, isn't that so good? Mathematical apparatus that gives the status quo the aura of logical inevitability. The numbers don't lie. Basically, you can put bias in and get bias out, but it looks like it's not bias because it comes from a machine. So this creeps in no matter if, for example, Amazon built an AI tool that was supposed to help them with hiring. They stripped out all the identifying data that would like show that someone was a woman, but it still picked up on stuff like Wellesley is a woman's college, so if someone went to Wellesley, like they're less likely to get hired. So in the future, they're less likely to get hired. And they had to scrap that. Same with Word2Vect, which is something that Google trained on, I think it was Google Books texts. Google News texts, even worse. And it basically, they constructed this language model, this model of language, the way that words relate to each other. But what they found is that when they plugged in like, you know, London is to England as blank,
is to Japan, it came out with Tokyo. But then like woman is to blank, as man is to doctor, and it came out with homemaker, stuff like that, not great. So in order to build actually good AI so that we don't end up representing, like generating stuff without AI that replicates the existing biases that are already embedded in the model.
This is a big lie, by the way. They don't smile like this.
Exactly. Yeah, but when you tell like DALL-E or something to generate a selfie with different types of people, it makes them all do the like selfie smile, which obviously they wouldn't actually like be doing. So a great resource for learning more about this is this documentary Coded Bias, which is by Shalini Kantaya and also Joy Bulawani, who also created the I always say this wrong, Algorithmic Justice League. I did it. Okay. So minimal and purposeful ways to decide whether or not to use particular types of technology. Just because we can doesn't mean we should, kind of thing. So for example, do you want your pacemaker to have Wi-Fi and Bluetooth? Maybe, maybe not. Do you want to be able to view, to look at the firmware that they're uploading with it? When there's an update, do you want to have to sign over consent? Do you want to be able to see what they're putting on there? Do you want to be able to review it for security risks, stuff like that? And if you can't do that, do you actually want that in your body? So building open source tools is, of course, huge for preventing stuff like that. Also, of course, when you have a piece of technology that's smart and convenient and magical, but it doesn't work on a large segment of the population, then you have problems, and it's not actually magic. This is all kind of obvious, but one of the concerns about like how much tech to put in your project. So, for example, for voice control technology, there's a lot of voice assistants, smart voice assistants that run offline and that are privacy focused. So, for example, Pico Voice on microcontrollers, Raspy, which is a Raspberry Pi based offline voice assistant, and Mycroft and Pycroft, which is the Pi version of it. But it is a privacy-focused voice assistant. So you can have the magic house, but with less risk. And that's what the original version of Archie here, the bigger one that's on the table out there, was designed to do. It was built with a Google AI Vision Kit, which allows it to supposedly look at your face and detect emotions and then respond accordingly, which of course is going to have some variation on how it responds to different people. But I wanted to use it to highlight the fact that you can do stuff like that without it ever sending data up to somebody else's cloud. So it can do it completely offline. You don't have to have it talk to anybody's server. You can always do it at home. Smoothly integrated and accessible. So there's a lot more accessibility now with AI. People have access to ChatGPT and stuff like that. But again, thinking about when we deploy this and the fact that it's not magic, it can actually have vast impacts if we deploy it when it's immature. So for example, Amazon has been marketing its recognition software to different police departments, and that actually has actual impacts on people's lives, as well as, this stuff can have really deep impacts if it is deployed in the wrong context. And so much of this stuff is about context and like, how mature is it? Can you use it for just a project? Or is it ready for a product? Is it ready for the real world? Most of this stuff is obviously not. And that's partly supposedly what this AI open letter was about, where people like Elon Musk are saying, we should have a hiatus for 6 months on the training of AI systems more powerful than GPT-4. Saying that, where is it? Ensuring that systems adhering to them are safe beyond a reasonable doubt. So they should not be deployed until they can be vetted, which is a little bit funny to me because there was this response from Timik Gebru, who was fired from Google's AI ethics board for basically writing about AI ethics, as is the case with actually a lot of the signatories here. So Microsoft, Google, Meta, and Twitter have all cut their AI ethics teams. And it's true that you do need to deploy AI once it's mature and once it's ready. But also, if you have experts on your team, listening to them is a good idea. So they put out their own statement, which is, very rightfully pointing out that regulatory efforts should focus on transparency, accountability, and preventing exploitative labor practices using the expertise of people who are available to you. And most of this stuff comes from the people using it, not from the tech itself. It's all contextual. A good thing to do is to note the limitations of your technology. So this is a cool thing that OpenAI did, which is like, guys, don't just like run out and put this everywhere. You know, sometimes it writes plausible sounding but incorrect or nonsensical answers. It's very good at being convincing. It's not great at being right. And also there's not really a way to tell whether it's right or not until you're like a human fact checking it. Machines just like can't differentiate that stuff. And obviously even humans have problems with it too. So again, back to how it affects how I build robots. This is my little guy, and I'm basically building out a few different firmwares for it. So one of them is going to be TinyML based, that's going to be able to hopefully detect a pitch fed into it from an ocarina. I'm going to play an ocarina. It's going to respond based on the pitch that I play or the tune I play. But I also can do a similar thing with a fast Fourier transform on Arduino. And also, I'm coming up with like other types of software that I can run on it that will, for example, read the different sensors connected to the Arduino Nano 33 BLE Sense on there and report them through like coded chirps, which I think will be really fun. I think with the creativity in this community and all the vast amounts of intelligence in the tech community in general, we have the smarts to think of awesome ways, awesome things to do with this tech, and awesome ways to use it that are thoughtful. And so we really have no excuse, and also it's more fun when it's nice to people. So invisibility, obviously back when Google Glass was a thing, RIP, it caused a lot of controversy because on the one hand, it's really magical when you have like LEDs embedded behind a piece of wooden veneer or like some transparent black LED acrylic, and suddenly they light up and you're like, oh, there's smarts here, it's magic. That's really cool. But also, we got to think about like whether or not we want it to be invisible. So there's stuff that comes up around consent, which is why I built this robot, which has an Arduino Nikla Vision in it, which looks at your, just looks out, it's got a camera on it, and then if you hold up a QR code, the consent QR code, then it'll take a photo. But if you don't hold up the consent QR code, then it won't take a photo. And I think making things obvious in that way, for example, having like a red LED to show that you're filming something, just giving feedback to everyone in the world about what your technology is doing, it is less magical, but it's also a lot better for everyone involved. And then finally, positive and life improving. Ideally, graceful or elegant technology should be good in the, in the overall sense as well. So one thing that I've been working on for a while, I don't have a recent picture, but is a raccoon-themed therapy robot companion because I can't have pets at my house. And I consider this very much like a world good to have a little robot that I can like hug. And you can use it for astronauts, you can use it in, what do you call them? Residences for all kinds of people who can't have pets. And I think this is a great type of project. But that's not the only cool thing you can build. So I've been building this page called green-EE, which is, as it says, a directory of resources for building helpful electronics in a sustainable, ethical, and thoughtful way. So everything from like a project that you're doing one of, to like building a whole corporation. I want to have links. I've got some resources for every step of the process, and also a directory of project inspirations. So if you're like, I really love UAVs, or I really love machine learning, or I really love rover robots, there's all kinds of cool stuff you can build with that will actually like help the world and allow you to explore your passions while also building something that will help people out. And I think that's really cool. So I'm collecting as many examples of this as possible on here, just for inspiration. That's about all I got for you. So I'm on Instagram, I'm on Mastodon, I am still on Twitter, I got LinkedIn, and you can follow me on Hackster to see what new weird projects I am publishing. And I would love it if you come and chat with me and ask me questions or share your own experiences and your concerns as you're building your own technology. Once again, all the links are up here. Thank you.
Thanks, Alex. You want to do some Q&A?
Sure. I do want to make one of these into a telepresence bot because, you know, if I can send a robot instead of myself, that'd be cool.
Questions, anybody?
Hey, Alex, what do you think about the idea of having bias bounties in the same way? Like, so since they've eliminated all their internal groups, what if we had some way of having them all pitch into some sort of external groups that check?
I love that idea. Bias bounty. Yeah. So that if you found one of those examples like, oh, every time I put in a picture of beautiful woman, they're all thin, you know, kind of thing, where it's like imposing this kind of bias on there. I think that'd be amazing. Because even internal teams can't think of everything. I love that. I'm really interested in this concept of like imposing the standards of beauty when we're doing these image generators and stuff. Like, that's so interesting.
Can you describe a little bit the base of your the base of your robot? What is the hardware that you use?
Yes, actually, this gives me a great excuse to talk about one of my favorite projects, the Companion Core, which is a PCB that I built to make it easier to build companion robots. It's got this skeleton design that I love, and basically it enables you to hook up.
Can you slow down a bit and just describe a little bit the first image?
Oh yeah. So just describing the first image here, it'll help if I show this one first. So on the top of the board, we've got basically, this is the prototype, so it's not the actual PCB, but you've got a breadboard with a microcontroller plugged into it, in this case an Arduino Nano 33BLE Sense, and that's stuck onto this board, and it's connected to headers on the side that you can use to connect servos and things.
What is the board on top that you have?
It's an Arduino Nano 33BLE
Arduino
Sense.
Nano. And the other one is
This
just
one.
a breadboard. This is it, right?
Oh yes, that's a breadboard.
And the one on top is?
Arduino Nano.
No. That's
This one?
previous. What is this now?
This is the Companion Core. This is the PCB that I built.
This is you're doing.
Yeah.
Okay.
It's not an Arduino, so it talks to the Arduino basically. The Arduino sits on the breadboard and is connected to this. It's basically a breakout.
Okay,
like a
that's
fancy breakout.
breaking out the signal of the Arduino
Yes,
on
and
top
it allows
of this.
you to power the servos independently of the Arduino and also hook up things like speakers and stuff. But also it makes it easy for you to swap out different controllers if you wanted to switch to a Teensy or you wanted to use this microcontroller across different projects.
Okay,
and
then
swap it back in.
say that I want to start a project with that. Where do I buy this?
Oshpark. So oshpark.com. You can find the link at the top of the tutorial. Maybe not the top. Here we go. Or the most recent version from Oshpark here. And they are a US-based PCB producer. I don't get a commission or anything. You just like order it from them because it's open source. And yeah, I don't remember. Okay, so it's $20 and you would get 3 of them for that. And I ordered them in the After Dark colorway, which is black FR4 PCB substrate with clear solder mask and gold Enig coating on the traces, which is fabulous. And then a white silk screen.
Okay.
You can also get it in purple. There's both versions here. But I like the black one.
Any other questions for Alex?
I'm going to put out a tutorial for like a really sort of general how to start building a companion bot, because that's a question I've gotten a lot. But we also have a community that's specific for those on Hackster with all kinds of people's open source tutorials.
Love it. Thanks,
Cool.
Alex.
Thank you.
Thank you, guys. If you like this talk, you might also like reading a pop sci tech book called You Are a Thing and I Love You. Yeah? Nice.
Oh,
So-
it's so live.
There we go. All right, our next talk is in 9 minutes at 3 p.m. and it's going to be make boom boxes.
Thank you.
I won't.
stream from yours?
Gonna try something else.
We can use AirPlay. You on Windows? Go ahead into your display settings.
I was gonna do single display.
You know what's system because it wasn't working. Okay, and your displays. You're in Windows?
No, it's Ubuntu.
I
can try again.
Does it do AirPlay?
I can do mirror in my display. It was doing extending it. I think that was the problem.
I thought it was crapping out completely.
No,
I'm
I think
sorry, I misunderstood.
I think it had a problem with the too big of a display.
No
some
problem.
video, but I think if I mirror, it's going to be.
Can you do Chromecast? So I can take a Chromecast.
Do you have a laptop? I can send you the presentation. It was just. I think a cable has a little bit of a. It worked last time.
Spray and pray.
No, it did work last time.
Is this the power?
Yeah. It's a Google spreadsheet I can share with an email.
It's a Google Sheet?
Yeah, it's a Google Sheet.
Oh, yeah. Share me on the Google Sheet. I'll bring it right up.
No.
No big boxes. .com. Okay. I'll bring it up and then I'll give you a mouse.
Okay. Oh, something. What?
It's like flickering though.
No, I'm just gonna mirror. Apply.
It's not too happy. No.
Okay, I got it. Yes. Okay, perfect.
What was the issue?
I just mirrored that it was extending you first and then you mirror, but it was some other issues. Oh, cool. I got some.
I'm feeling pretty good.
Some.
Noel, are you recording? Are you recording?
It's okay. One box should be okay.
Sweet. Okay, thanks for your patience. So our next talker is Murtad.
Murtad, yes.
Founder of Ubo, yes. Locally famous Raspberry Pi-based platform for building rich UI applications. He's building hardware products for the last decade, and now he's going to share some of what he's learned about that with us.
Thank you for the introduction.
Yay.
We already have a microphone. Thanks for joining the talk. Today I just wanted to share some lessons that I have learned during hardware development that I have done over the last decade. I can probably share everything in a 12 minutes talk, but I wanted to contrast hardware development with software development, and then things that you can do during hardware development to de-risk and also expedite your hardware development cycles.
It's okay, it's like we're at a rave.
But
Yeah, let's put a pin in it for a second and I'll pull it up with what you just shared with me.
All right, okay.
Give me a second. You can chat while I get that going.
Okay. So basically, when you are doing software development, comparing software development cycles and hardware development cycles, there are some differences. For example, every time you are iterating on your hardware, you have to make something and then test it. Versus in software, you don't have the make process. I mean, you are doing a make process, but it's very quick. So you don't have to wait for the part. Even if you're 3D printing, you still have to wait for the 3D printer to make it. So there's a build cost. I'll call that a build cost. So you have to kind of minimize your build costs in software hardware development, because the more builds you do, the higher cost of development you're going to have. Also, when you make a mistake in software development, you can always do a software patch or push a new update, software update. But in hardware, you can't do that. Like if you make a mistake, you just have to scrap that hardware, put it in the trash, and then basically you lose all the money that you've spent in whether it's a prototype or a production hardware. It better not be a production hardware, because at that point you go bankrupt, because you have to scrap all the production that you have done. And then the testing, software testing, you can write unit tests, integration tests, regression tests, different kinds of tests, and run it. In hardware, there's the same concept of testing, but when you're doing hardware testing, you need test rigs. Now you have to make another piece of hardware to test your hardware with it. So there's a test rig. You have to build these test rigs, which adds another layer of complexity to hardware development. So overall, your hardware build cycles are going to be minimum of weeks. So every iteration you go through, you're looking at maybe a month or two for each iteration. You can maybe do one iteration for months, but 2 months is kind of the average into your design iteration. For software, you can build something and release it in a week. So it's way faster development cycle. And then basically your time to ship in hardware is minimum 1 year. Like I've really never seen any hardware that from the idea to the moment it ships is less than 1 year. Like it's minimum 1 year, usually 2 to 3 years from the ideation to the shipping of the hardware. Software, you can probably ship in a month or two if you're doing an MVP or a very similar experience with your software. Now, the things that I have learned from the past is if it's the first time you're designing hardware, you have to be very careful with your environmental risk. The thing that I call environmental risk is that eventually your hardware where is it going to get deployed? Is it an outdoor product? Outdoor product, I think, is one of the most challenging categories of hardwares that you can ever build, because outdoor you have sunlight, rain, snow, a hailstorm, or every kind of thing that you can imagine. I'm on the third slide.
Third slide. Okay, there you go. Click. Good?
Yep.
Okay.
Gonna make it a slideshow.
Make it a slideshow. All right. So now you won't be hitting the space bar though, you'll have to click it. And it's a funky mouse. Good?
Perfect, thank you. So you're dealing with corrosion when you're outdoor, humidity. So you have to go with IP ratings. So IP68 is probably very high bar for like being dust proof and also weatherproof and all that kind of things. But to get IP rated, you have to go to an environmental testing lab that they will put salt on your product and see if it's going to corrode or not in the outdoor environment. And they're going to have spray water jet from different angles at the product to see if the water is going to get in. And there are so many, and the sand and the different grains of sands, that you have. So your iPhone is not really considered an outdoor product in that sense, but it's still, they have to go through so much environmental testing. So as a first-time hardware, if you're doing hardware for the first time, I would highly encourage you to stay out of these kinds of environment, the hostile environments where you deploy your product. And then people are going to drop your product if it's like, they're going to carry it, or even the postal office is going to drop your package. So you need to, consider that as a risk in your product development. Humidity, if you're developing something that is used in a bathroom or it's a smart toothbrush or something like that, then even little humidity can go inside and corrode your circuit boards and damage everything over time. So all these are like, you have to think about different levels of environmental risks. So for the first time product, I would suggest you go for safe places like a home environment or an office environment or something that is more controlled in terms of the environment that you're operating. So that's why I kind of went for Uber product, which is developer facing. When your customers are also developers, they might be more forgiving with the bugs in your product, because they can go and fix it. If it's open source, they can see, oh, I found this bug and I do a pull request and I'm going to fix that bug for you. So, but if your customer is a consumer and you have a bug in your product, now you have an RMA and they're going to send it back to you, and you have to provide the shipping label and everything to get it back. So there's also another layer of complexity in the type of customer or the user that you're dealing with. Now, what's this one? How do I go? Now, imagine now that you're settled on what you want to build or for what environment you want to build for, there are ways you can use to accelerate your product development. The thing that I have learned about hardware is that sometimes this happens a lot with Kickstarter projects, that they launch and they have a delivery date 1 year from now, and they say we're going to have to make it because people are waiting for it, so they start developing really fast. And go fast and break things might work for software, but in hardware, that's a recipe for disaster. So in hardware, it's really as slow as fast. In Navy SEAL, they have an expression that say, slow is smooth is fast. And that actually happens in hardware development. So that means that you have to take every step, test everything between every step of the way, make sure that you're standing on the solid ground before you step up and do the next thing in your hardware development. So going too fast can increase your build cost. So you can send something to China to get 3D printed, will shipped here in about a month and cost you $10. But then you can actually if you want it tomorrow, you might have to spend $1,000 to get it built tomorrow. So if you can wait, you can also lower your build cost. So one of the things that I usually do is that if I need something 2 months from now, I'm going to place the order now and pay way less for that and waiting until I need it. And it's like, oh, I have to now place the order. It can dramatically reduce your cost in hardware. Just thinking ahead of time what you're going to need when, and 2 to 3 months is really what you need to think in advance in hardware with prototype. With production, you have to think next year where I want to be with production, because injection molding is going to be 60 days, 2 months to wait for the mold, and another month to get your samples. So you're looking at very long lead times, and there's not really much you can do. I mean, you can insist to make things faster, but it's not going to happen. And then one thing that is very important in your design is that when you design things, you have to keep two things in mind. Is this easy to manufacture? Because if you make your design in a way that uses standard manufacturing processes and even cheaper ways to manufacture it, it's going to make life much easier for you down the road. So if you use laser cutters, it's a very easy way to manufacture. But if you need to do die casting of aluminum, then it's a very complicated way of manufacturing. And then DFA is usually neglected. DFA stands for Design for Assembly. Now, Design for Assembly can remove a lot of issues down the road when you start assembling your product together. So for example, there are very techniques for assembly that you cannot assemble it in a different way. So they removes the areas of basically confusion. You can always use that screw here. You cannot misassembly. And that was developed by Toyota, developing an assembly. I forgot the term for it, but it's like a self-correcting or self-supervising assembly technique that you can. It's like IKEA furniture. When you get the IKEA furniture, you cannot really mess up with the assembly because they make the screws or things like that a specific screw can only align with a specific hole. And you want to also minimize your number of iterations. There's always a temptation to do another iteration. But it's best to wait until you have a whole bunch of changes made and validated in the software, in the CAD software, in your design before you spin out another iteration, because and make is going to be costly, and you want to address any known issue or any design change that you want to do and validate it before you do an iteration. Yeah, so basically you also need to document all the procedures, everything that you go through, so that you can communicate that to the factory down later. Next thing that you have to keep in mind is that don't wait until you're ready to manufacture your product to talk to a factory. The way I usually start the hardware product development is that I have a very rough sketch of the product idea, and it might change a lot, but I know that at some point I may need an aluminum part or I need an injection molded part. So I start conversation with multiple factories and see which one is going to support me throughout the product development. Because when you work with the factories in China, if you do not place an order for more than 5,000 units, you're not an interesting customer for them. But you actually want to find a factory that is interested in helping you build the product at a smaller units. And so that means that you have to start the conversation early and see who is going to be willing to work with you along that line. So with some of the factories, like I start just as soon as I have an idea for the product or have a sketch, I start a conversation with the factory, and they're probably going to build something for me 1 year after I start that conversation. So they need to kind of stick with me during that year and kind of help me. And for them, it's just going to we're going to stick together and manufacture this product for many years. So think out of the box a little bit. There are so many different manufacturing techniques that you can use to lower your build cost. You can do aluminum extrusion. So I have this part. You can think of extrusion as pushing something like a paste or a toothpaste through a profile, and this thing kind of comes out like this as a tube. So you got the molten aluminum pushing like a toothpaste through a cutout profile, and it kind of comes out. And extrusion is very cheap compared to other ways of making a product. And so this thing will come out of an extrusion die like a bar, and it gets cut into pieces, and then they will machine it, post-process it on a CNC machine. So that's actually you can extrude plastic, you can extrude many different kinds of material, and it costs $1,000 to make an extrusion die. Or even less than that. All the frames in the office here, you see, they made custom extrusion profiles for them for just connecting these frames of offices. Vacuum forming is a very low-cost way of making things, especially if you're doing a small volume. It basically heats up a sheet of plastic and then sucks it around a form of object, so it kind of forms around a solid object, and it gives you that kind of profile. I'll talk more about compression molding. Compression molding is like a waffle maker. So we use compression molding for silicone keypads. They're the same keypads that you have on your remote control TV remote control. They're kind of flexible silicone products that you use it for keypad. But they have these sheets of silicone, and they put it in a waffle maker and they close it. So with the pressure of closing, and it heats it up and vulcanizes the silicone inside the mold, and then they open it like a waffle maker and they take out the part and do some cleaning, and you have a keypad, a small keypad that it's the same technique used for remote control silicone, and it's super cheap. You can make a single cavity mold for $200, but they usually ask for production. You have to make 20 of these at the same time in a 20 cavity mold, which costs around $1,000, but still a very low cost compared to injection molding. So another suggestion or recommendation I have is try to modularize your design as much as you can, so that you can test your modules and do like subcomponent testing. And then when you bring everything back together, you at least know that your subcomponents are individually unit tested, and then you would do an integration testing at the end. It's not trivial. I mean, some products you may not be able to modularize it, but when you look at it, like your computer has a standalone RAM, or a graphics card. So these are modules. So if you can kind of build these as standalone modules that you can swap them out. Also, it helps you in repair. If something fails, you can just swap that module and repair that. You can nowadays build PCBs with kind of with desktop pick and place machines. And desktop pick and place machine, you can make PCB boards, small, numbers of them, 10 or 50, before you're ready to move to a full-fledged production line for the PCBs. China is right now kind of like doing things. You can do things in China that is kind of going back in time. It looks like magic to me. Like you can 3D print things for $1 now, and like it's the same cost of doing injection molding. Like this piece, I can 3D print for